Evening everybody, welcome back to the channel. As crops mature, weeds start to appear above the canopy. So let's talk weeds. Over the last few weeks, I've shown you our efforts to combat weeds using mechanical weeding rather than conventional chemical methods. So the question is, why? I have two reasons for limiting my herbicide usage. Firstly, the cost. If by virtue of my low input system I'm going to have less yield, I need to limit my chemical spend. I have managed to reduce my fungicide spend by investing in disease resistant genetics, and the hope is that lower nitrogen crops will be less lush and so will be less susceptible to disease. A simple analogy could be drawn with obese people who suffer more from medical complications due to carrying extra weight. Now, weeds and the resulting chemical spend is harder to mitigate. We've invested in taller and more vigorous varieties to help combat weeds, and we also use mechanical weeding as a method of control. We could go for off-patent active ingredients in an effort to reduce the spend. 2,4-D is an old but effective broadleaf weed herbicide. However, this active ingredient is mentioned regularly for its persistency in Rachel Carson's famous book Silent Spring, published all the way back in 1962. In addition, underlying any chemical intervention in what is a biological system is the law of unintended consequence. A point raised by Dr. Elaine Ingham on her Soil Food Web course was that only a few of the thousands of soil-dwelling species have been cultured and studied in a lab. We know so little about their interaction that a herbicide intended for a specific weed could have an effect on a beneficial organism's life cycle, either directly or indirectly. So any product could pose a detrimental threat to this integrated and delicate web of interactions. Now, mechanical weeding, even if less effective, does mitigate the need for chemical intervention. I'm coming around to the opinion that unless a weed has a significant economic impact on a cash crop or impairs mechanical harvesting, I live in fear of a big clump of cleavers moving into my combine, we can tolerate some plant diversity within our crops, especially if the weed is at ground level and doesn't impact on the cash crop's canopy. Now to a quick example of our old friend Blackgrass. So whilst talking about weeds, I think it's worth just pointing out this section of Blackgrass in the bottom of this valley down here, where the soil type gets heavier. It's able to support blackgrass, whereas the rest of the field is relatively blackgrass free. If we pan across the field, this was sheep grazed mustard planted on the 1st of January, and you can see again at the far end of this field where the land gets a little bit heavier. Obviously you've got this valley running just in front of us here. It runs across the field and then links up with the other blackgrass section, so obviously a little bit stronger through the middle here, and then down the far end another chunk of blackgrass in this corner,
And it's interesting on this farm, which is relatively light, how you can just pick up just different seams of soil type, just enough to help the blackgrass. And interestingly, the next field on in a sequence, which is winter wheat, when I first arrived at this farm, that had one of the worst blackgrass infestations, and obviously that's progressively higher clay content and closer to the veil. So it really is on quite a knife edge here, and the chalk just enables the ground to be that much more free draining and less friendly to blackgrass. Here we are a little bit closer. You can really see it in a strip running down there.
I was reminded this week that the farming system creates an environment for different weeds to thrive in. I was reminded of this when my agronomist reported an outbreak of rye brome in a particular block of winter wheat. The bromes are a particularly tricky group of grass weeds. Bromes thrive in min-till situations like ours, but in order to control them, you have to identify which brome you're up against. Firstly, they can be split into two groups: the Anisantha species, including great and sterile brome, which have long awns and loose floppy heads, whilst meadow, soft and rye brome form the bromus species and have short awns and tighter flowering heads. You need to break the natural dormancy of the seed before you can target it with glyphosate, something that is easy with great and sterile brome, but is more difficult with the other three. A stale seed bed will induce dormancy of bromus species, so it is better to leave them on the surface and then go back in a month's time. So meadow, soft and rye brome often ripen later, meaning seeds, if you bury the seeds immediately after harvest, you will put them into a dormant state, which helps the seeds survive. So it's better to leave the seeds on the surface so sunlight will break the dormancy and enable the brome to grow when it can be controlled with glyphosate. So that's our current weed struggles for this week. Please subscribe, click on the thumbs up. It really does help the ratings, and thank you very much for getting us over 1,000. We'll see you next week.